Virabhutta sir, for your nice introduction. Is my voice clear to all of you?
Yeah.
Yeah. So due to some technical problem, it got delayed. I'm sorry for that. Let us start the lecture straight away so that we can use maximum time for sharing the knowledge. Okay, just. So what I have planned today, so let me write over here. So I will be talking about little bit of trigonometry, so which I need. Okay, trigonometry, because my setup have changed, so my handwriting also not looking good. So just a moment, if I can make it comfortable. So little bit of trigonometry, because as I've been told that some of the students are from class 9, so they may not be familiar with this concept. So I'll be introducing the concept of trigonometry, means some functions, trigonometric functions. Okay. Then next, I'll be going to discuss a very important theorem, which is known as extended sine law. Okay, and I have in my card to discuss another important theorem. This is Sever's theorem. So, which is another result which is very useful in solving geometry problems. Okay. So let us start with trigonometry first. Trigonometric functions. You might heard about this functions, sine functions, cosine functions, and tangent function. Okay, so let us see what are this. Now before this, let us see how this function comes. Okay, let us take this triangle OAB. I call this angle to be theta, and I'm taking this angle to be 90 degree. Okay, and I consider one more set of A and B's, that is A1, B1. Rather take one more, A2, and then B2, and take this angles 90 degree again. So what we can say about these triangles? Triangle OAB, triangle OA1B1, triangle OA2B2. To make the session interactive, I would like if anyone of you can give the answers. What we can say about these triangles OAB, OA1B1, and OA2B2?
Sir, all of them are right angle triangles.
Right angle triangles. Anything else?
They are similar.
They are similar. Very good. So if they are similar, then what we can say about these ratios? OA by OA1. Say if I concentrate only on these two triangles, we can say that OA by A1, then OB by OB1, and AB by A1B1. All these are going to be same, right? And if I use this from there, I can say that OA by OB is equal to OA1 by OB1, right? Now, if I also use this pair of triangles, I'll be able to write that this is equal to OA2 by OB2. Okay. And if I have more triangles like this, then all these ratios are going to be equal, right? All these ratios are going to be equal. Similarly, I can also say that OA by AB, you can see from this first ratio and the last ratio, you can write OA by AB is equal to OA1 by A1B1 are going to be same. And this is again, if I consider the third triangle also, then I can write it OA2 by A2B2 and so on. All these ratios, if I keep on considering such triangles here, so these ratios are coming out to be same. Okay. And another ratio that we can form is out of it is this one. What is it? O B OB by AB then equal to O B1 by A1 B1 is equal to O B2 by A2 B2. All these are going to be equal. Okay. So we have three sets of ratios here, three sets of ratios, which are coming out to be constant. So whatever size may be the triangle, okay, so if I go with this angle theta, whatever may be the size of the triangle, these ratios are coming out to be equal. So these constant ratios are referred as are given three names. Okay, so what are these? And remember, this constant ratio depends on theta. Okay, so these names are dependent on theta, so that's why we call this OA by OB to be still finding it difficult to make it convenient. Just a moment, if I can make some changes. Right, just a moment. I have to change my system quickly, and the new system I'm finding it difficult. Right. Okay. This constant ratios, we refer it as this. If you see, as we know, in a right angle triangle, we refer so when we consider a right angle triangle like this, we call this to be hypotenuse Okay, with respect to this angle theta, we call it base, and sorry, this is perpendicular with respect to theta, and this is base. Okay, so in that reference, you can see that this OA by OB is nothing but the ratio of this hypotenuse and base. Okay, and OA by AB is the ratio of hypotenuse and perpendicular, and OA by AB is last one, OB by AB. OB by AB is nothing but the ratio of the base and perpendicular. Okay, so these ratios are coming out to be constant. So that's why we can use this constant ratios for a given theta. Okay, to be can be given a, so if I consider this as theta, this as H, this as P, this as B, then this whatever may be the size of the triangle doesn't matter. This H, P by H, this ratio going to be same. We call this to be sine of theta. Okay, then B by H is called cos of theta. Okay, and P by B is referred as tan of theta. Tan of theta. Fine. Okay. The problem is that I am unable to see the tip of the pen because of change of this, and that's why I could not write properly. Okay, but this is just a rough idea about trigonometric function. But if I want to give you the complete idea of trigonometric function, I have to take help of rays. Okay, so let us give you the complete idea of trigonometric function. For that, I consider two perpendicular axes, call it as x-axis and y-axis. Okay, so this is the point of intersection O, referred as origin. Now this side of the triangle is my this side of the x-axis is my positive side. Okay, positive side. This is the convention we are fixing at the beginning, and this is generally used everywhere. This is the positive side of y-axis, and from O onwards, this is the negative side. Okay, negative side, and this is the negative side of the y-axis, x-axis, sorry, negative side of x-axis. So we have understood what is positive side, negative side, and so on. Now let us define angle here. So what is angle in this setup? So if I consider a line like this, ray like this, let this be OP. Okay, I'm very sorry, I'm unable to deliver as expected by you because of this technical problems. So this is line OP. Okay, line OP, and how we define this angle, how we define this angle? Actually, it is the rotation of this OP starting from the position OX in anti-clockwise direction. So this is my angle theta. Okay. So what is angle theta? It is the rotation of this line OP starting from the position OX. Okay. So how much rotation it is taking place? That is my angle, and also fixing the direction of rotation to be anti-clockwise. Okay. Now from this P, I drop perpendicular here, and as a result I get a right angle triangle. Okay, so I call this base of this to be point where it intersect x-axis to be n. Okay, now how can I define these two terms? How can I define these two terms, Pn? So what is Pn? Pn is the displacement of P along y-axis. Okay, so that is what I am mentioning here. And what is On? What is On? On, I will say it is displacement of P along x-axis. Okay, along x-axis. So since it is displacement, so it can be positive or it can be negative. Okay, but what is OP? What is OP? OP is the distance of P from O. Okay, so under this setup, what we can say now is that the possible sign of Pn may be positive or negative. Positive sign of On may be positive, negative, but OP is always positive. This is always positive. Okay. Now, under this setup, if I use my earlier definition of sine theta, so what is going to be sine theta? Sine theta going to be Pn by On. Sorry, Pn by OP. Okay. What is my cos theta? Cos theta going to be On by OP, and tan theta going to be Pn by On. Okay, so this is the definition of. Now suppose I want to know I know the value of this sine theta, cos theta and those, but I take this theta to be not clockwise, it is in anti-clockwise direction. Okay, so instead of taking it to be in clockwise direction, I take it in anti-clockwise direction. So the rotation now taking place in this direction. So if it is anti-clockwise, clockwise, then definitely we will be considering the angle to be not theta, it is minus theta. Okay, so under this setup, what is my P? So this point is P, this point is N. So what is sine of theta? Sine of theta, sorry, not sine of theta. It should be sine of minus theta. Sine of minus theta. So this is equal to Pn by OP. Pn by OP. But how do you compare Pn with the previous Pn? You see, if I draw this line, call it P dash, which is the reflection of P on x-axis, then this is going to be the triangle. Okay, and in that case, if I take the rotation here, this is going to be theta. Now, how can I compare this Pn and P dash n? You can see that this Pn is nothing but minus of P dash n, minus of P dash n. The reason is that P dash n is the displacement taking on along the positive direction of y-axis, whereas Np, the displacement of P, is taking along the negative direction of. So in that case, it is P dash n, and OP is same as OP dash. Okay, OP is same as OP dash. So what we are getting then, this is equal to minus of sine theta. So this gives you a very interesting and useful result. What is sine of minus theta? It is equal to sine, minus, this is equal to minus sine theta. Fine. Similarly, you can show that what is cos of minus theta from here. Cos of minus theta going to be for that it will be ON by OP. So ON is positive side for both the triangles, so it will be cos theta. Okay, it will be cos theta. So it is sine is not going to change. Okay, and tan theta, definitely tan of minus theta going to be minus tan theta. The reason is that your perpendicular is in opposite direction for both this triangle, but the base is same. Okay, in the positive side of x-axis. That's why tan theta will remain same. So we have a very nice result now, that what is sine theta, sine of minus theta. Okay. Now we would like to know what is sine of pi by 2 plus theta. So this is our next aim to get. So what is sine of pi by 2 plus theta? Sine of pi by 2 plus theta. First of see what is sine theta. Okay, so if I take this to be my theta, okay, this is my suppose point P, then how can I get sine of pi by 2 plus theta? So I have to rotate this OP another 90 degree, right? So for that, let us take this point to be P dash. So this angle going to be pi by 2 plus theta, because already theta rotation I have taken, and then this is 90 degree. So pi by 2 plus theta we got. Now where we are in P dash position, right? So again, if I use the definition, I have to draw perpendicular from P dash to x-axis. So this is going to be my n. Okay. Then what is sine pi by 2 plus theta? So for this pi by 2 plus theta, OP dash is the hypotenuse, P dash n is the perpendicular. Let us call it as Pn dash instead of Pn, and On dash is the base. Okay, so with this, sine pi by 2 plus theta going to be P dash n dash by OP dash. Okay, but if I draw perpendicular from P to x-axis again, from here what we can say is that this Pn and P dash n, they are going to be same, and in fact sine is also going to be same, because Pn gives you the displacement of P in the positive side of y-axis, and P dash also gives you the displacement of P dash along the positive side of y-axis. Using geometry, we can say that P dash and dash are same in magnitude, so their sign same. That's fine. Okay, but what about On and On dash? On is on the positive side, but On dash in the negative side. Okay, that is, they are equal and opposite in sign. But OP and OP dash, they are going to be same. Okay, because OP, as you have seen, OP is the distance of P from O, and distance cannot be negative. So OP dash is exactly equal to OP. OP dash is exactly equal to OP. So what we are getting then? This is same as sine theta. Okay, this is same as sine theta. But when I take cos of pi by 2 plus theta, it is going to be different. So what is cos of pi by 2 plus theta? Now base is ON dash, hypotenuse is OP dash. OP dash is same as OP, but ON dash and ON, they are equal in magnitude but opposite in sign. So I will be writing here minus ON. So this gives you minus ON by OP. So that means it is minus of cos theta. Okay. And using this two, you can say that tan of pi by 2 plus theta is also going to be minus tan theta. Okay. And if I combine this result, I can also move forward and write what is cos of, sorry, let's write first sine. What is sine of pi plus theta? What is sine of pi plus theta? I can write this to be sine of pi by 2 plus pi by 2 plus theta. So that gives me, if I consider this to be my theta, this portion to be my theta, then it is sine of, what is sine of pi by 2 plus theta? Let's see. Sine of pi by 2 plus theta is sine theta. Did I made some mistake? Yes, I made some mistake. What is the mistake? I did a big blunder here. Just a moment. Let me. This should be cos theta. Yeah, geometrically, what I did here, this should be theta, not this one. This should be theta. So in that case, this is 90 degree. Then this is not cos theta. Sorry for the mistake. This is not cos theta. This is actually sine theta. And this is not sine theta. This is cos theta. Sorry for this mistake. This is sine theta, and this is going to be cos theta. And the role of this ON dash and OP, P and P dash N dash will change. Okay. So it is. So what we are going to get here then, this is cos of pi by 2 plus theta, and then finally it is minus sine theta. Fine. Then what is cos of pi plus theta? So this is equal to sine. Same way, if we break it, this is cos of pi by 2 plus pi by 2 plus theta. So this is equal to minus sine pi by 2 plus theta. So this is equal to minus cos theta. Okay. So these few results I will be required, okay, to discuss the problems on geometry. Sorry for this little confusion that I have created. Hopefully will not make any mistake out of it. Just a moment, let me clear if I have done any mistake here, further mistake. So cos of pi by 2 plus theta is on dash by op dash. But here, yes. So the problem here, what is going to be equal is OP equal to OP dash, that's fine. But PN dash is equal to ON, and yeah, P dash N dash equal to ON, and PN equal to O dash N dash. So in that case, this is not ON by OP. So this is OP fine, but P dash N dash is nothing but ON, and that's why it is coming out to be cos theta. Similarly here, this is not ON by OP. This is going to be minus ON dash is equal to PN by OP, and that's how it is coming out to be sin theta, minus sin theta. Okay. Now let's come to our discussion that we wanted to discuss related to geometry, that is extended law of sine. The extended law of sine. What it says, if I take any triangle, okay, if I take any triangle ABC, okay, then if I know that R is the radius of the circumcircle of this triangle, okay, then sine A by A, I hope the notations are you are familiar with it. Sine B by B, sine C by C is equal to 1 by 2R. Is equal to 1 by 2R. Okay, so this result is known as extended law of sine for triangles. Okay, now how can we establish it? Establishing this is not that difficult. Okay, let us do the reverse engineering. First you draw the circle and then you consider a triangle on it. So let us consider this triangle. So this is A, B, C. Okay, so we have center of it like this. This is the center. Now consider this triangle. Consider this triangle. Sorry. Call it to be point J and join it with this. Since I'm considering this to be the center, can you tell me what is this angle JBC? What this angle is?
90 degree.
90 degree, because it is half of the, it is over the diameter of it, right? So it is pi by 2, right? Now, if I consider this, then what is sine of J? So 90-degree angle is JBC. So what is sine of J? So I'm considering this angle J. So with respect to J, perpendicular is BC and base is JB and hypotenuse is JC. Okay. So if I use it, then sine J is perpendicular by hypotenuse, JC by BC. Sorry, BC by JC. Okay. So this is same as BC means small c, sorry, small a. Okay. And JC means it is 2r, as we are considering the triangle ABC over the circle. So if I consider r to be the radius of the circle, then this is the radius of the circumcircle, right? So a by 2r. How the angles J and A related? What is the relation between angle J and A? They are over the same chord, okay, on the same side of the circle. So they are going to be equal, okay. So therefore, what we can finally write from here is that sine of A is equal to A by 2r, okay. If you use the similar argument, you will be able to say that sine of B is equal to B by 2r, because we don't have any inclination towards the angle A. So same we can do with angle B, same process will be able to do with this. And sine C going to be C by 2r. Okay. And if you combine these three, you get this relation: sine A by A, sine B by B, and sine C by C is equal to 1 by 2r. And this relation is known as extended law of sines. Okay. Now quickly use this and let us derive some nice results on trigonometry. Okay, so which you may be familiar with. And then we'll move to triangles. For any triangle ABC, even B and C are obtuse or acute, it doesn't, B or C are obtuse, acute, whatever it is, we can write A is equal to B cos C and C cos B. In fact, we can write the same thing for B also. B will be equal to A cos B, A cos C plus C cos A, and C is equal to A cos B and B cos A. Okay, so these three results. So we'll be proving the first one, and the same way the second one will also. So let us take a triangle like this. So this is A, B, C. Okay. And drop a perpendicular AD from AD to B, from A to this. So this is perpendicular AD. Okay. So what we can say from here is that this BC, so which is nothing but your A, is equal to BD plus DC. Okay. Now, if I consider this right angle triangle ABD, from there, what we can say, BD BD is equal to AB cos B. And from right angle triangle ADC, we can say that DC is equal to AC cos C. Okay, and that this gives you the result. AB means small c cos B, and AC means small b cos C. Okay, but we can use this to so for if one of this angle is not acute, it is obtuse, then also you can get it. It's not that difficult. Okay, so but what I wanted to tell you is that if I want to know the angle, sine of the angle B plus C, how can I get it? If I want to know what is sine of B plus C, how can I get it? Okay, see, this is what I want to know. Okay, since A is equal to B cos C, C cos B, so we can write from here. Now go back to the extended law of sine. What it says, extended law of sine, it says that sine A by A is equal to 1 by 2R. Okay, so we can replace A with 2R sine A, right? So we can replace A with 2R sine A. So we can write here, it is 2R sine A. We can replace B with 2R sine B into cos C, and we can replace C with 2R cos C into cos B. Okay, so we are replacing this A, B, and C using extended sine law. Now, if you cancel this 2R, so what you are going to get is sine of A is equal to sine B cos C, sine B cos C plus cos C. Sorry, this is not cos, this is sine C. So this is sine C cos B. Okay, but what is A? A I can write as pi minus A plus B. Okay, sorry, pi minus B plus C, because A plus B plus C is pi minus B plus C. So this side is sine B cos C, then sine C cos B. Okay. Now, just now we have seen that this is equal to sine of minus B plus C, because sine of pi plus theta, we have written it to be sine theta, right? So if I treat it as pi plus minus B plus C, then it is sine of minus B plus C. Okay, so this is sine B cos C plus sine C cos B. Okay, but what is sine of minus theta? That also we have derived. Sine of minus theta is what is sine of minus theta?
Minus of sine theta.
Minus of sine theta. Then where is the problem? I think oh, this is not sine theta. Pi plus theta, sine of pi plus theta we have written as minus sine theta. Sorry. So this is minus sine theta. Then this will finally give you sine of B plus C. Sine of B plus C is equal to sine B cos C plus sine C cos B. So you might have seen this, those who are already familiar with trigonometry, this formula. See, we have a geometrical proof of it, but you can use this extended sine law to prove this result. Sine B plus C equal to sine B cos C plus sine C cos B. Okay. So likewise, if I want to write now sine of B minus C, what will be it? I can write it as sine of B plus minus C. And if I replace this C with cos of minus C, as you know, cos of minus C is cos C. So it will be sine B, cos of minus C is cos C. So it is cos C. Now sine of minus C is minus sine C. So it will become minus sine C cos B. So this is the formula for sine of B minus C. Now I want to know what is cos of B plus C. So what is cos of B plus C? I can write this to be sine of pi by 2 minus B plus C. As you know, we have proved that sine of pi by 2 minus theta is equal to sine theta, cos theta. Okay. So this you can see it very easily. So this I can write as sine of pi by 2 minus B, then minus C. So this is one part and this is another part for me. So let us use this sine B minus sine C formula. So what we will be getting? Sine of pi by 2 minus B. So that is same as cos B. Okay. And then cos of C. So that's fine. Cos C. Then sine of C. Sine of C. Sorry. Minus sine of C. Then cos of B. Cos of B here is cos of pi by 2 minus B. So it is cos of pi by 2 minus B is sine B. So this is the formula for cos of B plus C. And likewise, you can get cos of B minus C also. That is going to be cos B cos C plus sine B sine C. Okay. So what I want to note from here finally is that what is sine of A plus B plus sine of A minus B? This is equal to 2 sine A cos B. Okay. And what is cos A plus B plus cos A minus B? This is equal to 2 cos A cos B. So likewise, if you take the difference, you will be getting 2 sine B cos A for sine A plus B minus sine A minus B. And for cos A plus B minus cos A minus B, you will be getting 2 sine A sine B. Okay. So let us try few problems quickly. We have still 20-25 minutes. Using this ideas. Okay. So take these problems. Let ABC be an isosceles triangle. Isosceles triangle. Okay. With AB equal to AC. So these two sides are equal of this triangle. Suppose the angle bisector of angle B meets AC at D, and that BC is equal to BD plus AD. Okay. So question is, find what is angle A. Let us draw a representing diagram. So we have an isosceles triangle here, like this. Okay. So this is A, this is B, this is C. Okay. And what we are given is that these two sides are equal. AB and AC are equal. Next, what we are given is that we have drawn this angular bisector of B, bisector of the angle B. So bisect this angle B and let this touch this side at D. This is given. Okay, so what we know is that this angle and this angle both are same. So let this be called alpha. This is alpha. Fine. Then what is this angle? Because it is an isosceles triangle, ABAC same, so this is going to be 2 alpha. And what this angle is? It is going to be pi minus 4 alpha. Okay, pi minus 4 alpha. Then what is this angle? So this is pi minus 4 alpha. This is alpha. So this is going to be 3 alpha. So if this is 3 alpha, then okay. Next, what we do, you from D you draw one line to touch the side BC at E in such a way that this DE is equal to EC. Okay, so take E on C, E on BC, such that this DE equal to EC. DE equal to EC. Now join this A with E. What we can say from here? We are taking DE and EC same. So this is also an isosceles triangle DEC. So this angle also going to be 2 alpha. This also going to be 2 alpha. Okay. Then what we can say about this angle? What we can say about this angle? This is going to be 180 minus 5 alpha. So if it is 180 minus 5 alpha, then this angle going to be 4 alpha. Okay, this angle going to be 4 alpha. Fine. So what we get in this quadrilateral A, B, E, D? What we get in this quadrilateral? Angle A plus angle E is equal to 180 degree. Okay, and this means what? ABED is
cyclic
cyclic.
quadrilateral.
As you know, quadrilateral is cyclic if and only if the sum of its opposite angles is 90 degree. Okay, so we have a cycle around this ADE. We have a cycle from around this. Fine. Okay, so BDE. Okay. Now what we know is that BC is equal to BD plus AD. Okay. And we also know this is equal to BE plus EC. Okay. So this implies that BD plus EC, as AD we have taken same as EC. So EC is equal to BE plus EC. And this implies that BD equal to B. BD equal to B. Fine. So if BD and BE are same, then what we can say about this angle?
Sir, AD and
BDE.
EC are how equal? So can you explain once?
Am I making a mistake? If you consider this ADE triangle, so what do you know? Is AD is equal to DE. Okay, AD is equal to DE, and this is equal to EC. AD, DE, and EC, they are same. So from there, we are getting actually AD equal to EC. We have already taken ED equal to EC. Assumption was that if you see from here, we have taken E in such a way that DE equal to EC. Okay, and AD and DE are same. So from there, we are getting AD equal to EC. Is that clear?
Okay, sir.
So BD equal to DE we are getting. So from here, what we can conclude then? Angle BED is equal to angle BDE, and one of them is 4 alpha, so the other one is also 4 alpha. Okay, so therefore what we can say now, that angle ADC is equal to 3 alpha plus 4 alpha plus 2 alpha. Okay, and that means ADC is a straight angle, so it is 180 degree. So the other side is 9 alpha. That means alpha is equal to 20 degree. Alpha is equal to 20 degree. But what is angle A? Angle A we wanted to know. So this is equal to 180 degree minus 4 alpha. So that gives you, it is equal to 100 degree. Okay. Now look into this problem. So many construction is there. Okay. And using this construction, somehow we could be show that this angle is, we could find the angle A. Okay. But why I wanted to discuss this problem is that now what we are going to do, we are going to solve the same problem. Okay. But using this extended sign law. And you'll see that this comes so quickly using extended sign law. No construction in fact is required. Okay, no construction is required. So let's start with the same problem. So what is given to us? We are given one isosceles triangle. Okay, one isosceles triangle ABC. Fine. And we are given the angular bisector of B, which is in touching BC at D. So let us take this to be alpha. This is also going to be alpha. That is what we know. And since it is isosceles triangle with these two sides same, so if angle B is 2 alpha, this angle is also going to be 2 alpha. And this is going to be pi minus 4 alpha. Quickly we can get it. And this angle going to be 3 alpha. Fine. So this is what we have. Quickly we can get. It is not that difficult to get. Now you use this extended sign law. Okay, in triangle, extended sign law in triangle A, B, D. So what are the angles we have in extended sign means in this triangle? One is alpha, the other one is 3 alpha, and the third one is pi minus 4 alpha. Okay, so if I write one by one, sine of pi minus 4 alpha. Okay, so what is the opposite side of this pi minus 4 alpha? Is BD. It is the size BD. So this is equal to, what is the then sine of 3 alpha? What is the opposite side of this? It is AB. And finally, sine alpha, what is the opposite side of it? AD. Fine. And using the property of ratio, I can say that these ratios are also equal to, sine pi minus 4 alpha plus sine alpha plus sine alpha. So I'm taking first ratio and second ratio and divided by divided by BD plus AD. BD plus AD. And that's give you, what is BD plus AD? What is BD plus AD? It is given, you see in the problem, what is BD plus AD given to be? BC, right? So we get it to be equal to in the denominator, it is BC. But what is sine of pi minus 4 alpha? It is sine of 4 alpha plus sine alpha. Fine. And Hence, what we are getting is that sine of 4 alpha by BD, as you know, sine of pi minus 4 alpha is sine 4 alpha, is equal to sine 4 alpha plus sine alpha by BC. Fine. This implies that BC by BD is equal to sine 4 alpha plus sine alpha by sine 4 alpha. Similarly, if you consider the triangle, other triangle BCD, okay, if you consider the triangle BCD, so similar type of results you can get from there. Okay, so what we'll be getting from there is that BC by BD. Okay, so first we took ABD and then we are taking BCD. Okay, so if I take BCD, we will be getting BC by BD. BC by BD is equal to sine 3 alpha by sine 2 alpha. So I'm skipping this because it is not that difficult again. So BC by BD means, so I'm taking BC. So if I consider this angle, what is this angle? This is pi minus 3 alpha. So BC sine pi minus 3 alpha by BC, that means sine 3 alpha by BC is equal to sine 2 alpha by BD. Okay, and that from there you can get BC by BD equal to sine 3 alpha by 2 alpha. So that's what we are getting here. So if I combine these two, so what we are getting? So therefore both are equal to BC by BD. So we are getting sine 3 alpha by sine 2 alpha is equal to sine 4 alpha plus sine alpha divided by sine 4 alpha. Okay. If I simplify this, I get here is sine 4 alpha sine 3 alpha. Okay. Sine 4 alpha sine 3 alpha, and this side going to be sine 2 alpha, then sine 4 alpha plus sine 2 alpha. Okay, I can make one quick change and make it as make it simple. Sine 3 alpha by sine 2 alpha, and this is equal to, as you know, sine B plus C is sine B cos C, cos B sine C. So in that way, sine 2 alpha plus 2 alpha, I can write it as 2 sine 2 alpha plus into cos 2 alpha. Okay, so I'll be able to cancel this sine 2 alpha. Sine 4 alpha sine alpha. So from here you can cancel this sine 2 alpha, and that gives you what? 2 sine 3 alpha cos 2 alpha is equal to sine 4 alpha sine alpha. Okay, so now everything is trigonometry. Okay, now this I can write as 2 sine A cos B. I can write as sine of 3 alpha plus 2 alpha, that is 5 alpha, plus sine of 3 alpha minus 2 alpha, that is sine of alpha. So this is equal to sine of 4 alpha plus sine of alpha. Okay, so from here sine alpha goes out. Okay, and this gives me sine of 5 alpha equal to sine of 4 alpha. From here, what I can write? 5 alpha equal to 4 alpha, or I can write one more thing, because I know that sine 5 alpha is equal to sine pi minus 4 alpha. Okay, so I can write this to be 5 alpha equal to pi minus 4 alpha. This is not possible. This is not possible because alpha is greater than 0. Okay, so only possibility remains is this one, and that gives you alpha to be equal to 20 degree. Alpha to be equal to 20 degree. Okay, so that means angle A is 100 degree. So what you can see is that simply we are using this extended sine law here, no construction, nothing. But whereas in the previous problem we have used construction and solve the problem. Okay.